Data is growing at over 40% year over year. This means most customers are doubling their storage every 2 years. Though the cost of storage is going down, it's not going down fast enough to offset this data growth. And this is proving out to be a great challenge for most IT departments. Are there other options that are available to customers today to build cost-effective storage solution? With Windows Server 2012 R2 and System Center 2012 R2, you now have the ability to build an enterprise-class storage solution with industry-standard components. This now gives you the ability to get the performance, the reliability, the availability, and the efficiency that traditional storage has provided you, but at a fraction of the cost. I'm Prabhu Rambhadran. I'm a Senior Product Manager in the Windows Server and System Center Product Management team. We're going to talk about how we are transforming storage with Windows Server 2012 R2 and System Center 2012 R2. Before we get into the details of what we have with Windows Server, it'll be a good idea to spend some time understanding what you would find inside traditional storage. If you break open a SAN, what are you going to find inside? You would essentially find a whole bunch of physical disks. These are arranged inside disk shells. So these could be regular spinning disks or SSDs or a combination of both. On top of these, you would have storage controllers. Most of these SANs have more than one storage controller to give you redundancy and high availability. And the storage controllers decide things like data deduplication, thin provisioning, trim unmapping. And to a large extent, these storage controllers are like x86 servers. They have memory and other server-like architecture that are used to build them. And this essentially builds your SAN. And the storage that you have is exposed through dedicated adapters. So these adapters could be fiber channel over Ethernet, or iSCSI. So this is all that you would find inside a SAN. So some proprietary software here, a bunch of physical disks, and a dedicated adapter to expose your storage. What we want to do with Windows Server 2012 R2 is to provide you the same functionality, the same performance and efficiency that you would get with a solution like this, but at a fraction of the cost for most of your workloads. Let me show you what I'm talking about. Just the way you have disk shells, you would essentially have low-cost industry-standard JBODs. JBODs are just a bunch of disks that provide you raw physical storage. And managing these JBODs would be Windows file server nodes. These JBODs could be regular spinning disks, SSDs, or a combination of both. And these Windows file server nodes are connected to the JBODs using regular SAS connectivity. This way, even if one of the connections fails, you still have continuous access to your storage. And the Windows file server nodes are clustered together for high availability. Again, if one of the nodes fails, you still have the other node exposing the underlying physical storage. Windows File Server introduced storage spaces, a storage virtualization technology in Windows Server 2012. With storage spaces, you could pool a bunch of physical disks together and create what we call storage space. Storage space is essentially a virtual disk. Just the way you would carve out LUNs on top of underlying physical storage in a traditional SAN, you do the same thing with storage spaces. Here it's a virtual disk or a storage space and create a volume on top of it. Windows Server also introduced data deduplication in Windows Server 2012. And you also have functionalities like thin provisioning, trim unmapping, and so on to give you that efficiency. And when we talk about exposing this storage to your Hyper-V nodes or SQL Server, you could do it using your existing network infrastructure. So these could be 1 gig NICs, these could be 10 gig NICs, 56 gig NICs, or 100 gig NICs. We've done optimizations at the networking level with technologies like Smb Direct, which gives you hardware offloading in terms of data transfer. So what you essentially do is create a volume and then create an SMB file share on top of it. So your SMB file share, which you've done since the Windows Server 2003 days, is essentially the storage location for your Hyper-V VMs, your SQL databases, and so on. And you'd get the same level of performance that you would get with fiber channel connected storage. So you essentially have your Hyper-V nodes connecting to this SMB file share to store the VMs or the SQL databases. The biggest advantage of a solution like this is you could thinly provision your storage and scale out depending on your needs. So you could hot add storage when you need them, or you could add more compute power when you need them. So it lets you scale storage independently of compute. So we spoke about storage spaces, which is a storage virtualization technology that we introduced in Windows Server 2012. Let's talk a little bit more about it to understand what storage spaces is all about. What I have here is a JBOD. It has a combination of SSDs and regular spinning disks. As we spoke earlier, SSDs gives me the performance, and regular spinning drives gives me the storage capacity. Instead of managing all these individual disks with storage pools, which is my first level of abstraction, I could manage disks at a pool level instead of individual physical disks level. So a storage pool is essentially an aggregation of multiple disks. In this storage pool, I have a bunch of SSDs and regular spinning disks. Let's say that this is my dev test environment. And I might have another pool, which is my archive environment, where all that I care about is just raw storage capacity, but not performance as much. And all that I'm going to add there would be regular spinning disks. So this is the first level of abstraction that I have. The next level of abstraction that I have is what we call storage space. Storage space is very similar to the LUNs that you used to in the SAN world. With storage space, you essentially create a virtual disk that sits on top of the storage pool. And you could choose to assign whatever disks that you want from the pool to a specific storage space. Not only that, it also lets me define a whole set of properties that are associated with that virtual disk. In terms of resiliency, I could choose whether I want two-way mirroring, three-way mirroring, two-way parity, three-way parity, or just simple striping. So depending on the workload that I have, I could choose the appropriate resiliency level. In terms of performance, because I have a combination of SSDs and regular spinning drives, we have a technology called storage tiering, where Windows automatically keeps track of data usage patterns and moves data that gets used all the time onto the faster SSDs, and data that doesn't get used all the time to the slower spinning disks. So like I mentioned, with a hybrid storage model, you essentially get the performance of SSDs, but the capacity of regular spinning disks. The other thing that you could do is pin specific files to a specific tier. For example, I have an SSD tier here and a regular spinning disk tier here. If I have a SQL database that I want to guarantee consistently high levels of performance, I could essentially pin that database onto the SSD tier. Similarly, if there are files where I don't care about performance as much, I could pin them to the slower spinning disk tier. The last thing that I want to talk about is efficiency. When you create these virtual disks or storage space, you could either thinly provision them or do fixed provisioning. This way, you could create a virtual disk which is larger than the amount of storage that you actually have, and add storage only when you need them. Once you create the virtual disk, all you need to do is create a volume on top of it. This volume provides a storage location for your VMs or for your SQL databases. What you've essentially seen over the last few minutes is how we are democratizing storage with Windows Server. With technologies like offloaded data transfer, virtual fiber channel, you're essentially maximizing your existing storage investments. But with storage spaces, storage tiering, data deduplication, all built into Windows Server, you get the same level of performance, resiliency, availability that you're used to with your traditional storage. All that you need is a Windows Server box and a bunch of disks. Give it a try.